The Sun is the most important celestial body in our solar system. It is the center of our solar system and the source of all life on Earth. In this video, we will explore the fascinating facts about the Sun, its structure, and its role in sustaining life on our planet. The Sun is a massive ball of hot gas, primarily composed of hydrogen and helium. It is about 109 times larger than the Earth and has a mass of about 330,000 times that of the Earth. The Sun is located at the center of our solar system, and all the planets, including Earth, orbit around it. The Sun is the primary source of energy for all life on Earth. It provides light and heat, which are essential for the growth of plants and the survival of animals. The Sun's energy is also responsible for the Earth's climate and weather patterns. The Sun's surface temperature is about 5,500 degrees Celsius, and its core temperature is about 15 million degrees Celsius. The Sun's energy is produced through a process called nuclear fusion, where hydrogen atoms combine to form helium, releasing a tremendous amount of energy in the process. In the next segment, we will explore the Sun's structure and how it produces energy. The Sun has several layers, each with its unique characteristics. The outermost layer is the corona, which is the Sun's atmosphere and is visible during a total solar eclipse. The layer below the corona is the chromosphere, which is a thin layer of gas that appears red during a solar eclipse. The layer below the chromosphere is the photosphere, which is the visible surface of the Sun. The photosphere is about 500 kilometers thick and has a temperature of about 5,500 degrees Celsius. It is a layer where the Sun's energy is produced through nuclear fusion. The Sun's energy is produced in the core, which is the central region of the Sun. The core is about 25% of the Sun's radius and has a temperature of about 15 million degrees Celsius. In the core, hydrogen atoms combine to form helium, releasing a tremendous amount of energy in the process. The energy produced in the core is transported to the photosphere through a process called convection. Convection is the transfer of heat through the movement of fluids. In the Sun, hot gas rises from the core to the photosphere, where it cools and sinks back down to the core. The energy produced in the Sun's core takes about 100,000 years to reach the photosphere. Once it reaches the photosphere, it is released into space in the form of light and heat. This energy is what sustains life on Earth and drives the Earth's climate and weather patterns. In the next segment, we will explore the Sun's magnetic field and its effects on Earth. The Sun has a powerful magnetic field that extends far beyond its visible surface. The magnetic field is created by the movement of charged particles in the Sun's interior. The magnetic field is strongest at the Sun's poles and weaker at the equator. The Sun's magnetic field has a significant impact on Earth. It can cause solar flares and coronal mass ejections, which are massive eruptions of gas and charged particles from the Sun's surface. These eruptions can cause geomagnetic storms on Earth, which can disrupt communication systems, power grids, and satellite operations. The Sun's magnetic field also creates a solar wind, which is a stream of charged particles that flows out from the Sun in all directions. The solar wind interacts with the Earth's magnetic field, creating the auroras, also known as the northern and southern lights. The Sun's magnetic field goes through a cycle of activity, with periods of high activity and low activity. This cycle lasts about 11 years, and during the peak of the cycle, there are more sunspots and solar flares. Scientists study the Sun's magnetic field to better understand its effects on Earth and to predict space weather events. Understanding space weather is essential for protecting our technology and infrastructure from the effects of solar storms. In the next segment, we will explore the Sun's impact on the formation of the solar system. The Sun played a crucial role in the formation of the solar system. About 4.6 billion years ago, a cloud of gas and dust collapsed under its gravity, forming the Sun and the planets. The Sun's gravity pulled in most of the gas and dust, leaving only a small amount to form the planets. The planets formed from the leftover material, which clumped together to form larger and larger bodies. The inner planets, including Earth, are rocky and dense, while the outer planets are gaseous and less dense. The Sun's position in the solar system also played a role in the formation of the planets. The inner planets formed closer to the Sun, where it was too hot for gas to condense into solid particles. The outer planets formed farther from the Sun, where it was cooler, allowing gas to condense into solid particles. The Sun's energy also played a role in the formation of the solar system. The energy produced by the Sun's nuclear fusion process created a solar wind, which blew away the remaining gas and dust in the solar system. This process allowed the planets to form and prevented the formation of additional planets. The Sun's position in the Milky Way galaxy also played a role in the formation of the solar system. The Sun is located in the Orion arm of the Milky Way, about 25,000 light-years from the galactic center. The Sun's position in the galaxy has allowed it to remain relatively stable, providing a stable environment for the formation and evolution of life on Earth. In the final segment, we will summarize the key points about the Sun and its importance to life on Earth. In this video, we have explored the fascinating facts about the Sun, our star, and the source of life on Earth. We have learned that the Sun is a massive ball of hot gas, primarily composed of hydrogen and helium, and is located at the center of our solar system. We have also learned that the Sun's energy is produced through a process called nuclear fusion, where hydrogen atoms combine to form helium, releasing a tremendous amount of energy in the process. The Sun's energy is essential for the growth of plants and the survival of animals, and it drives the Earth's climate and weather patterns. We have explored the Sun's structure, its magnetic field, and its impact on the formation of the solar system. We have also learned that the Sun's position in the Milky Way galaxy has allowed it to remain relatively stable, providing a stable environment for the formation and evolution of life on Earth. In conclusion, the Sun is a remarkable celestial body that plays a crucial role in sustaining life on Earth. Understanding the Sun and its effects on Earth is essential for protecting our technology and infrastructure from the effects of solar storms. We must continue to study the Sun to better understand its impact on our planet and the universe.